In this video, let's see how we can use MATLAB to plot data and to format figure. We'll also use the built-in function findpeaks to locate all peaks automatically. After we locate the peaks, we'll extract the individual peak data and save the data into new files on your computer like this. We have 4 peaks here, and we'll save each peak data into separate files. In our code, we'll also integrate the peak area and have the integrated area colored and plotted in the figure separately. As in your system, the peak area may represent some physical meaning. Here, we will use a short piece of data as our example. The data was originally from a TXT file. It contains around 300 data points. In practice, you may have data as many as this, or it can go to millions of data points. Before diving into the detailed code, let's first consider the outline of our approach to the task. In the first place, we plot a figure like this from the original text file, which contains 2 columns of data. We can specify the font of the axis, the font of the title. We can specify the color of the data points, the color of the line. Once we obtain the locations of all the peaks from findpeaks function, we'll loop over every individual peak and create an empty file named after the location of the peak to save the data of that peak. The way we extract the peak data is to reference the peak position and move from that position to the right of a user-defined number of data points, as well as to the left. We then can save all the data, both from the right-hand side and left-hand side, into the previously created file. Of course, we'll also sort the data in order so that it will be sequential. The same operation can be done over every peak. So we'll have as many files as there are peaks in the data. Meanwhile, all the area of the peak will be integrated and recorded in the separate figure. Now let's go to take a look at the code. There are 3 parts of the code. The first part is to plot the figure. It's very straightforward. Just follow the syntax of MATLAB. Briefly, we take the first column of the original data file, as well as the second column, and name these 2 columns as your axis and plot them to the figure. Line 14 is to specify the title and subtitle of the figure. And from 15 to 17, we can specify the font and size of the title and subtitle. From line 18 to 21, you can set the X and Y label, and you can set the tick. Next section code is very short. Here, line 24 and 25. Here is to apply findpeaks function to your data with parameters you set. Here we specified the minimum peak prominence is 25, and this function can return you the peak magnitude, the locations of the peak, the width, and the prominences. Width here by default, it means for width at half max. So later you can access all this data simply with these variable names, peaks, locations, width, and prominences. Now we hold off the figure. Previously we hold this figure on to have this findpeaks function to analyze this figure. Now we hold it off because we are going to make new figures. Finally, in the third section, we make a nested for loop to iterate over every peaks as well as every individual peak data. The outer loop in our case runs 4 times. That 4 is the length of our vector here. In this for loop, we'll create the peak name one by one. Here, the naming of the peak, and here the directory of every peak file. We then specify a window size. This is a user-defined value, which is roughly half of the peak width. Here we set it as 15, meaning we'll iterate 15 times to capture 15 data points from that peak. Before moving on, we use a short piece of code, 3 lines here, to check if the peak file has been created successfully. This is not essential, but for assurance, we just put it here. And we create an empty matrix which has 2 columns and 0 rows, which can be later populated by all the individual peak data points. Now, this is a nested for loop. In this loop, we use interpol1 function to interpolate the data points at the location specified by this parameter. Here, the sample interval needs to be fixed so that every loop increment can interpolate one data point. And this value is basically the sample interval length, meaning the distance between two adjacent points. This minus sign is to interpolate to the left. We then create an array variable to store the interpolated data. This array has only one row and two columns. One row, two columns. And we append that array to the previously created matrix. We do the same thing to the right. Then we sort the data in order. Then we write the sorted peak data into the file. And we can give every peak its specific name. This section is to plot the individual peak. That is like this. Plot individual peak. And hold on the peak figure. We can fill the peak with color, and this trapz function is used to get the area under the peak. And this is some calculation. This is specific to the system, and then we give the title. Then that's the end of the code. Let's run and test it. You can see we obtained 5 figures. 4 figures of the peak and 1 figure of the complete data. For the peak figure, this looks like more than one peak. That is based on the parameters, filtering parameters that you apply to the findpeaks function. And the files are also saved in your computer. You can get the files. Here are all the figures, and these are the files of each individual peak. Or that's how we do this work. I hope you find this video helpful. Thanks for watching. Please don't forget to give me a thumbs up. Thank you very much.